So the purpose of this talk is to give you an introduction to Scalding. And in this talk, I will not focus on featuring all the coolest and fanciest things that you can do with Scalding, but I would like to give you a good start so you understand the key ideas. You will see some sample code that you will understand in detail, and then you will have pointers where to go on your own. Also, at the conference, there will be another talk that will go into some more deeper elements of Scalding. So I said that I'm going to do some drawing, actually. So you will see in the middle of my talk, I'm actually going to switch my computers. I will start with my drawing computer, and then I will switch to my Mac to show you some code in the IDE. So let's see what is the origin of Scalding and why would we need a thing like this. So imagine your goal is to write some big data programs. And the question is, how would you do that? And you have a couple of choices. One choice is you could use the Java API. It is a fairly low-level API. It gives you really good control. The problem is that this code is a little bit verbose, so you will need to do a lot of work in order to write your programs, and that will not going to make us very happy. In many organizations, even when you mention that you are going to use some programmatic or Java API, the data architects and similar, they're just going to frown and they want to have their beloved SQL or something that would be similarly easy. And the natural path of developing such applications is the invention of Hive. With the Hive, you have the language that is very similar to SQL. It is not exactly SQL, but it is pretty close, and the data architects get all very enthusiastic about it, and then eventually they start hitting problems. And that is the Hive is actually quite limited in comparison with real SQL, and you end up writing a lot of user-defined functions. To make things worse, you're writing these user-defined functions in yet another language, either Java with rather clunky API or Python. Another problem with Hive is when you write your large queries, they're extremely difficult to debug. And sometimes you have the problem that you have to write these queries in a rather declarative fashion. And you run it, and then in the third hour of your Hadoop run, something goes wrong. You have a null pointer exception. You have no idea how to troubleshoot it. So people figure out we need something that will enable us to write programs step by step so we can really understand what is really going on. And that is Pig. And a Pig also has a problem that it is relatively limited. You don't have any control structures. You end up writing, again, lots of UDFs. But it gives you a nicer, somewhat programmatic way of development your queries. However, there are big problems. So after the honeymoon is over, when you start developing real programs, you start to desire certain things. First of all, you start desiring test-driven development. Your programs are getting larger, and small examples don't work anymore. The other big problem is that you would like to include your programs into conventional DevOps. And this is just not working very well with either Hive or Pig. So as a result of these considerations, we had the invention of Scalding. And to understand how Scalding works, you actually need to see what is its foundation. So at the lowest level, we have the foundation which consists of Hadoop. Now, we have seen that using Java is very clunky with the native APIs that we have for MapReduce. But then we would still like to use a real programming language where we can use a test-driven development and we can have the full DevOps and write our big data applications. So that resulted in the creation of a Java library called Cascading. And this is the fundamental part of Scalding. So in this library, we have a mechanism that will allow us to access the Hadoop APIs, but in a very pragmatic, very efficient way, and with rather few lines of code. Of course, from our point of view, Scalding is still somewhat low level. We would like to have something nicer. And what is very nice, we have heard, are Scala collections. Now, Scala collections can be implemented so that they actually map their work to the Cascading API. I will tell you a little bit more about it in a moment. And this is the Scalding. So the Scalding will be using cascading API, and basically you will have that the Scala programs will be translated on the fly so that they use the cascading API, which in turn uses the low-level Hadoop APIs. Now, what is interesting about this today is that cascading does not run only on top of ordinary Hadoop and MapReduce, but also runs on top of Spark. And what is particularly exciting for us today, there is a project that is porting cascading on top of Flink. Who has heard about Apache Flink? Apache Flink is the new approach to implementing big data systems where you have the streaming paradigm as the dominant paradigm. So it's not the batch where you are then doing streaming with micro batches, but it is the streaming paradigm which is the foundation. And a stream that is a finite becomes your batch job. So this is very exciting. So one of the very exciting things for us today, and why Scalding is so interesting, is that it enables us a relative independence from our implementation infrastructure. And this is interesting for some of our clients. For example, when you're looking into Hadoop and Tez, you would say that this is a very good choice where the data is significantly larger than the total memory that you have on your cluster. If you have a different setup, so the memory is big enough, you perhaps may want to go with Spark. So with a Scalding setup, we can change our backends by retaining the same code. Now, one of the interesting things that you will see when I run some code is that the programs are organized in a paradigm that is using the pipes and filters paradigm. So we have a tap, which is our source, and then the data from here is going to be piped. You can imagine that you are building a real piping, and each of these is going to be the element in your program. You have pipes that are just carry data. You are going to find that there are some elements that will act like valves. But you also have some other elements that are going to do, for example, filtering of some data and just pass certain things that satisfy your criteria. And eventually, you are going to have your sinks. Now, what is also very interesting about these sinks is that you are not only dealing with HDFS and plain files, but you have a variety of different inputs. So for both taps and sinks, you have HDFS, you have also JDBC, you have HBase, you have Cassandra, MongoDB, and so on. So what is really interesting is that you can build your applications that are actually very heterogeneous. They consume the big data, but they can also merge them with the other data that you have in your system. So this is very important for many of our clients. When we think about these elements that are actually doing the processing, we have various capabilities that include things like filtering, projections, joins, and so on. And one of the really interesting things is that when you run this program, the program is not going to be directly interpreted like we have seen in various other approaches. Instead, what will happen is as you start executing your program, the first phase is going to be what? It's going to be to build an access plan. And this is something that you are going to find missing in many of the big data technologies, something that is perfectly normal in the relational world, and then this knowledge was forgotten. So what this compiler is doing, it is going to construct the path, it is going to calculate what is the optimal access path, it can do some optimizations, and then it is going to run this pipeline. So this is very interesting. All right. So at this point, I'm going to switch my computer and go to the IDE, and we are going to see some Scalding code. We are going to run it, and we are going to see what are the things that are happening there. Okay, so it should come up in a second. There we go. So I have prepared a couple of examples, and here we have a rather ordinary Scalding project. And the first project that I'm going to show you is the obligatory word count. So what we have here is a word count program in Scalding. It begins with the class that is going to accept certain arguments. And this class is going to extend a class job, which is taking the arguments. In this program, we are going to first start consuming our input. In our case, this is the input that you're getting from the text line. And what we have here is the mapping. So when I run this, I'm going to pass in the input parameter. And I will be using the data set, which is the book Alice in Wonderland. So this is going to be my input file. And then I will be using the output, which is the Alice word count.txt. So what I do here is I say text line with arguments input. This is going to open my input file, and it is going to create what? It's going to create a pipe. So this is something quite interesting in the Scala API. You are working with pipes that are going to look like Scala collections, and then you will be applying different transformations, like in a completely ordinary Scala collections. So the next thing that we are going to do is we are going to do the flat map here. Now, there is something interesting here, something that you don't have in the ordinary Scala collections. And this is this mapping. So the line is what is known as the input field. This is the text that we are getting. And the output of our flat map is going to be known as word. And then we have the function that is going to take the line, which is a string, and just we are going to split it using the spaces separator. So what we are going to have here is from the book, we are going to have a collection that contains words. The next line is interesting. We are going to do the group by word, and then what we are going to emit is the size of this collection. So for every word, you're going to have the list of all the words that have occurred in the text, and then we are going to get the size. And eventually, we are going to do the write, TSV, tab separated values, and we are going to write this into our output. So very simple, very similar to normal Scala collections. There is one small difference that you're going to find, and that is you always have the name of the input field and you have the name of the output field. So when you add that, you have a functionality that is very similar to the plain Scala collections. All right, so let's see how we would run that. Over here, I have prepared an SBT task that is going to execute our program. So I'm going to copy this, and you're also going to see something interesting, something that is different from normal Scala run. So I run that, and I'm going to open this and zoom in a little bit. So what is happening here is when you submit your Scalding program, it is going to run using a job runner. Job runner is a small utility that is providing this initial functionality. And then what you can notice here is that you have some information. So this is coming from the cascading. This is coming from the Java library, the version that we are using. And then you have the information about the pipe. And over here, we see what is the source. It is a file tab. There is a sync, which is a file tab. Parallel execution is enabled, starting job, and this is a small example running on one thread. What we are doing here is we are running Scalding in the local mode. And this is very cool because we can develop our programs locally. We don't need to deploy it on the Hadoop cluster. We can get feedback in a matter of seconds. And later, when we are ready for the actual deployment, we can go to the actual Hadoop deployment. So that is a typical run of a Scalding program. And notice what is happening here. We have immediately information about the source and sync. And this is because the path is first built, and then eventually optimized. And this information is coming from the cascading before it starts actually executing the program. A couple of other things that we can see as an example. So another very simple program that shows this pipelining in action is a simple file copy program that is going to copy one file into the other. So we open the input as a text line. We open the output, and these are pipes. And then what we do is we are going to start from the input pipe, read from it, and a result is pipe that we are going to write in our output sink. Now, what is interesting here is that when you run this on Hadoop, this is actually going to be the parallel copy that is happening across multiple machines. But as we are using it, we have the image of a fairly simple program. The other thing that we have here is a slightly more complex workflow where you can see some of the common elements of such programs. So here we are going to show a program that is going to do a variation of the word count, but it is only going to count words that are coming in from another file. So we are going to count only selected words. Here I have hard-coded our input. So input is a text line. What you have here is a pipe. Selected words is another pipe. And then we start building our code. So we say selected words pipe. We start from our input. Then we are going to read it. We are going to rename the line, which is the default name for the line in a file, with selected word. And we do that because in this file, each word is on the separate line. And then we are going to project selected word. So what is interesting here is that as you read in the file, the Scalding is going to have the first column, which is the line number. So we are going to get rid of the line number and retain only the word. We prepare our output, the text line, and then we start doing our join. So for our input, we are going to do the flat map as before. We do the group by, and then I'm going to execute here a join with tiny. I expect that the set of selected words is small, and what is going to happen here is that when I run this on Hadoop, this small set of words is actually going to be copied to each of the machines in my cluster. So I'm doing the join, and eventually I'm projecting the word and the size, and I write that in the output. So you see, it is very easy to construct the follow. It is very natural for Scala programmer who is familiar with Scala collections. What is also interesting, and that was actually quite surprising, normally you don't expect data architects in companies to be enthusiastic about Scala. Even when they see Java, they just don't want to learn that. They're looking for something simpler. But when you demonstrate the Scalding program, they see that it is, first, only a couple of lines of code. It is fairly easy to understand. And we had in one organization where very traditional DBAs and data architects started learning Scala just in order to use Scalding. And sometimes in organizations, you are going to hear complaints that Scala is way too complicated, that you cannot have Scala in this setting. And that is not true. When you think of Scala and its introduction in such environments, you need to think about 3 levels. 1, Scala as better Java. And this is mostly what we are doing here with very concise code. Then you have the introduction of the functional programming. For that, you will need some training. Otherwise, the people are going to struggle. And then there is the level where some people complain that Scala is complex, and this is for the development of complex libraries. And then you can see quite elaborate signatures. But what you need to understand is that there are very few people that will be operating at that level. And they do it for the purpose that everybody else has easier life and have type safety. So we have been introducing Scala in financial organizations. And in order to be able to be productive Scala programmers, we put the developers in a 4-day training. A normal Java programmer comes in, and they come out as the Scala functional programmer. And then it is very easy to add a little bit of akka to that and make them very functional. So this is an example of the Scalding program. So what is nice here is it is concise, it is easy to follow, and this particular program here is using an API which is called a field API. Most of the Scalding code out there is using this API, but there is a newer API that is now preferred the API, and this is the typed API. Typed API is giving us better type safety, and it is now the recommended API. You can notice here that in the variant of our word count, I'm defining what is the content of the pipe that I expect to have. So I say words is a typed pipe that has strings inside. And then when I'm talking about the groups, I have groups of strings and strings. And over here, when I'm looking into the output typed TSV, I have a string for the word, and I have a long for my word count. Now, Scalding does not end here. Scalding has additional libraries, and one which is very interesting for us is a library that comes really handy for machine learning and data mining and similar. And this is the metrics API. So you have the metrics library that operates on data that are coming from, for example, HDFS files, and this data can be sparse matrices. And the metrics API provides all the normal operations that you will find in metrics libraries, only it scales and it is handling the data in the HDFS scale. And just to give you a taste of that, here is one example where we are processing graphs. We are using the TSV metrics that has inputs of users and how are they connected with each other. So very simple. And we are calculating out degree. So what we do is we are going to read in the metrics, and we are giving the names to the columns. So we have a user 1, user 2, and the relationship that exists between them. We are going to read it. We convert it to metrics with these fields, and then we can use operations from this rich metrics API. And then eventually we write it out. So a very powerful set of capabilities. And finally, Scalding is a very active project. It has been developed at Twitter. The GitHub is quite active, particularly Wiki is improving. And you will see that one of the weaknesses of using Scalding that we had before, and this is the documentation was not always complete, is significantly improved within the last year. Wiki has much more comprehensive set of tutorials, and it becomes much easier to start with the system. And again, one of the situations where you would really like to use Scalding is when you are using ordinary Hadoop, and you would like to have the full programming language power instead of dealing with pig and hive deficiencies. And the other reason why Scalding is so interesting today is it allows us to decouple from the underlying platform. So we can run it on plain Hadoop, on Spark, on Flink, and we can easily survive the change in the infrastructure. So I will put these slides on the GitHub and the code examples. So by tonight, you should be able to find them there, by tomorrow at the latest. And what questions do you have? Right here. Right here. There is a microphone behind you.
How is the error handling done in the pipes? Is it like...
Excellent question. So how is the error handling done in the pipes? So one of the ways to handle the errors is that you can create a special pipe that is going to deal with exceptions. So all the exceptions will go into that pipe, and then you can put that, you can either do some processing. So for example, you receive the values and then you can notify somebody or you store them in the file. So you can imagine that there is a tab that is the exception tab. The other thing that is quite related to that, which you will use as you are developing your programs, is debugging. And that is, let me just go to my code here, word count job. One thing that I can do is, as I'm writing this, I can insert debug statement. And now when I run this, you will be able to see the output of this particular pipe. And that is very useful, especially the beginners often don't understand, so how does group by exactly work? And we should see now a bunch of output coming from this pipe. There you go. So you can see here I have inserted debug, and the result of group is coming out. So as you're interactively developing your programs in local mode, you have a good understanding, and we have found that that eliminates a lot of errors, and you get your feedback very, very quickly. So a very practical thing.
Thank you.
You're welcome. Any other questions?
Awesome. Well, if that's it, thank you so
Great.
much, Vladimir. Maybe
Thank you very
join
much.
me in thanking him for this.